Introduce you, Maarten. I guess that a lot of people already know you, but anyways. So I'm really happy. Welcome, first of all, to our Circular Industries Hub talks. And today we will have a presentation by Maarten Koese. Maarten is currently working on some stuff related to material flows, and he will be a PhD student in one of our projects that will start in July, the Resilience project, which is about the recycling of magnets, just that's a follow-up of the Suspect project. But in the meantime, Maarten has been working on some interesting stuff. We have been discussing this already quite a bit also in a session together with policymakers and people from the banking world, looking at what would be the impacts of basically the supply crunch that we have, partly because of COVID, but also nowadays because of the Russian invasion in Ukraine. Russia and Ukraine are both very relevant suppliers of raw materials, not only of the metals that we like to look at, but also, of course, of foodstuffs, the grain basket of Asia, basically. And there's a lot of discussion about the resources. We talked about Russian natural gas in Europe a lot, of course, but there's also battery-grade nickel coming from Russia. Platinum is a very important thing being produced in Russia. But Maarten will talk a lot more about the differences before I give it all away, basically, about the different materials that are related to Russia and Ukraine. And I think it's a very timely topic. I think it's a very nice topic, and I think it's a very interesting topic also because it's one of those. We're always talking about supply chain disruptions and system dynamics modeling of supply chains. This is a typical example of a supply chain disruption that is very instantly, basically. So this happened within a week or so. You suddenly had this disruption. So it's a very interesting case study of what disruptions can do to supply chains. So without further ado, Maarten, I would like to give you the floor and to tell us a bit more about what you found.
Yes, thank you. I will tell a bit more about the effects of the Russian invasion in Ukraine on raw material supply chains, especially on raw materials relevant for the energy transition. And I will also go into the geopolitical relations and dependencies that are exposed by this war. So first I will introduce the topic briefly. Then I will introduce a case study of electric vehicles and then discuss this topic based on this case study. Then I will go into the material supply chains of the materials present in these EVs. And then I will discuss EU dependency, followed by a conclusion and the Q&A. So as you all know, Russia invaded Ukraine on February 24. And millions of Ukrainian citizens fled their country as a consequence. And Western countries imposed heavy economic sanctions against Russia as a consequence of this invasion. And the current status of the conflict is displayed in the figure on the right, in the map on the right. Fights and bombardments are still going on, especially in the eastern part of Ukraine, the Donetsk and Luhansk regions. And Russia is currently targeting full control over the southern and eastern regions. And this has consequences for global supply chains and global trade. As you've seen in the news, it influences food trade and food supply. Ukraine is also sometimes called the breadbasket of Europe, and the grain produced in Ukraine can normally feed over 400 million people. And as a consequence of the war, food production and exports are hampered. Food production is hampered because the fields are destroyed sometimes, or there are not enough people present to work on these fields. And food exports are hampered because the Russians are blocking the harbors, and the exports mainly go through ship, and export by train is sometimes done as well, but it is a lot more difficult and it goes a lot slower. And according to the United Nations, up to 49 million people may suffer from hunger as a consequence of the war. And yeah, mainly people in Africa or the Middle East are dependent on food supply from Ukraine, so they will face the yeah, most detrimental consequences. Besides food, metal supply chains are also affected by the war. Both Russia and Ukraine, as Renee already said, are important in metal supply. Russia is a supplier of platinum and palladium and supplies around 40% of global supply of these materials. It also supplies both primary and refined nickel, and also copper and cobalt. And as you can see in the graph on the right, the nickel prices increased drastically after the Russian invasion with over 100%. And this caused the London Metal Exchange, the exchange on which nickel is traded normally, to stop nickel trade for a few days because of the steep price increases they were getting out of hand. So you can see that yeah, the consequences for these metal markets were quite high. And Ukraine is also an important supplier, mainly of titanium, uranium, iron ore, manganese, and graphite. And allegedly there are large lithium and rare earth reserves in Ukraine. And the European Union also yeah, made a strategic partnership with the Ukraine regarding raw materials in 2021. In these yeah, in this raw material supply from Ukraine, the Eastern Donbas region plays a crucial role because most of the reserves are located there, and the region is the industrial heartland of the Ukraine, and therefore a lot of industrial infrastructure is located there. And yeah, this leads some people to speculate that raw materials may be one of the reasons behind the Russian invasion, and also one of the reasons why the Russians are yeah, trying to take control over these eastern regions, especially now. Yeah, as this war shows, there is a paradox going on right now in Europe. On the one hand, the war increases awareness regarding EU dependency on Russian oil and gas, and this dependency boosts momentum for renewables, because renewables will make the EU more self-sufficient. But at the same time, the green transition requires materials, and these materials will have to be supplied by countries the EU may not want to be dependent on either. And if I take the nickel example again, nickel is an important material in many green energy technologies, for example, batteries. And yeah, nickel is required to make this transition, but a large share of it comes from Russia. So then the dependency is shifted from Russian gas to Russian nickel. So the question is, yeah, what do you succeed with that? And in the following slides, I will discuss the example of electric vehicle or EV implementation to explore the resilience of global material supply chains and changing geopolitical positions. The International Energy Agency, the IEA, forecasted that there will be 145 million EVs in 2030 worldwide. And in their net zero emission scenario, this amount is even higher, up to 260 million EVs in 2030. And as you can see in the graph on the right, this is mainly due to battery electric vehicles, and to a small extent also due to plug-in hybrid electric vehicles. And in the graph, you can see the EV sales will grow drastically. And this large growth comes with increased demand for materials, because these EVs have to be made from materials. And an important share of these materials is used for the batteries. And the graph on the left, you can see the market share of different battery chemistries, the past 10 years, but also forecast for the next 10 years. By the way, this data is collected by Yanan. I think she's also present in this meeting. So if you're interested in this, you should check out her papers. But yeah, you can see that in the graph on the right, that especially the batteries contain large nickel contents, but also considerable cobalt and lithium contents. And yeah, logically, the future demand of these materials is expected to grow as a consequence of EV implementation. And as you can see in this figure, especially nickel demand is expected to grow a lot to almost 2,000 kilotons, while lithium demand and cobalt demand are expected to grow as well, but to a bit smaller extent. And yeah, you have to remember this graph is only the demand of these materials as a consequence of EV implementation. And these materials may also be needed for other applications in the future. So demand may even be even grow higher than this graph shows.
Maarten, sorry to step in here, but could you go 2 slides back? I have a question of clarification.
Yeah.
Not sure. I think it's one back. It's the one with the, no, it is one further. Sorry for that. One further. No, it's the one with the graphs.
Yeah, I think the presentation may be a bit slower for you than I go through it. Is it, what graph are you referring to?
One slide further, please.
Yeah.
This one. Can you say briefly something about the abbreviations or the acronyms? I'm not sure whether you did explain it, but might also be that I'm not so rather new to this topic. What do the acronyms stand for?
Yeah, sure, I can explain. So the in the left graph, you can see below the names of the different battery chemistry types. Sorry for the noise. My neighbors are doing construction. I don't know if you can hear it, but
hardly.
Okay, that's great. So the abbreviations, NMC means nickel, manganese, cobalt. So these are the cathode types of the batteries. NCA, I think, is nickel, cobalt, aluminum. I'm not sure about the A there. And LFP means lithium, lithium. I don't remember the F.
Lithium iron phosphate.
Oh yeah, lithium iron phosphate, indeed.
Okay,
thank you. René.
This helps a lot for me. Sorry
yeah,
to
no worries.
Here.
Good that you ask. So these are the most important batteries currently on the market. And you can see that especially the nickel manganese cathode chemistries have the dominant market share currently and also in the future. So then I will continue with the rest of the vehicle, the material requirements in the rest of the vehicle. This also contains critical materials, especially rare earth elements are used for permanent magnets in the electric motor. And then I'm talking about neodymium, praseodymium, dysprosium, and terbium. And as you can see in the graph, the demand will also grow drastically for these rare earths. And especially neodymium demand will grow due to implementation in EVs, but also dysprosium and praseodymium demand. Terbium demand grows a little bit, but not as much as the others. And the same applies to copper. This is used in electric motors and for wiring and electronics. And according to the IEA, the copper requirement for one electric vehicle is 53.2 kilograms. So you can imagine the large amounts required to implement 145 million or even 260 million electric vehicles. And in the graph, you can see the primary demand increase as a consequence of EVs. So clearly, demand for these materials will grow drastically the coming years. And in their Metals for Clean Energy report, Grégoire et al. Provide an overview of the supply of these materials, these metals, and they also provide an overview of the supply that is currently being explored or developed. And if we compare their supply data with the demand data as a consequence of EVs, we can conclude that on the long term, supply risks do not seem likely. since most of these materials are sufficiently present in the Earth's crust. And however, on the short term, supply risks are likely, especially for lithium, nickel, cobalt, and dysprosium, and lower risks for copper and neodymium as a consequence of EV implementation. And this is because the materials are present in the Earth's crust, but it takes a long time to get them out. So if we decide we need more lithium next year, and we need to take it out of the ground on a new location, it may take 10 to 15 years before the mine is actually in operation and it supplies materials. And to make it even more difficult, most of these materials come from outside the European Union, and this may increase the risk of supply disruptions and constraints. And I will go into this further now. Cobalt mainly comes from the Democratic Republic of Congo, which supplies over 70% of the primary production. And this primary production in Congo is associated with high environmental risks, but also with child labor, corruption, and the financing of armed groups. And the market for cobalt is highly concentrated, both the primary as well as the refined market, because around 60% of the refined production comes from China. So most of primary cobalt from Congo goes to China to be refined there, which gives China a powerful position in the cobalt supply chain. Secondly, copper is traded on a competitive market for the primary supply and a moderately concentrated market for the refined supply. And 27% of primary copper comes from Chile, and 38% of refined production comes from China. So again, China is a powerful player in this market as well. Lithium traded on a highly concentrated market with over half of primary production from Australia, 25% from Chile, and 13% from China. And China dominates the refining and consumes over 50% of primary lithium supply, which gives China again a dominant position in this supply chain, but also a vulnerable position because China is dependent on other countries a lot as well for their primary lithium. Then nickel. Traded on a moderately concentrated market. Most of the primary production happens in Indonesia, also some in the Philippines and Russia. And Russia accounts for around 20% of the refined supply. And if you remember the slide I showed before, that the nickel prices increased with over 100% after the Russian invasion, this shows that even a country which accounts for 20% of the refined supply, which seems relatively small, for example, compared to cobalt or lithium, that this may already have very large risks on supply disruptions, as the invasion showed. So this means that if these disruptions would happen for example, cobalt, the consequences would be even larger. Then finally, the rare earth elements are traded on a highly concentrated market and mainly produced in China, which accounts for 61%, but also the US, Burma, and Australia produce rare earth elements. And the mining of rare earths is associated with pollution, a lot polluted water, and also nuclear wastewater. And this may cause health effects of in people, but also detrimental effects for ecosystems surrounding the mines. And China also controls over 90% of the refined rare earth supply, because, for example, Burma and Australia do not have the facilities to process these rare earths themselves. Thus, they are transported to China to be refined there. So it is clear that the green energy transition will create new dependency patterns for the European Union, from dependency on fossil fuel countries to dependency on raw material countries. And as has become clear, China is the most important country in many material supply chains, either due to primary or refined supply, or sometimes both. It is important for rare earths, cobalt, copper, and lithium. And the EU also relies on Congo for cobalt and copper, Chile for copper and lithium, Australia for lithium and nickel, and Russia for nickel, cobalt, and copper. And to a smaller extent also on Argentina, Indonesia, New Caledonia, the Philippines, and the United States. And yeah, it is questionable whether this dependency, whether the EU should want to be so dependent. Many of these countries are autocratic regimes, and they have a different value base, which may influence or complicate trade with these countries. For example, China decided to ban rare earth element exports in 2011 after a conflict with Japan over some islands in the South Chinese Sea. And as you can see in the graph on the right, this causes very steep price increases. And the rare earth market has only become more concentrated the past decade. So if an export ban like this would happen now, the consequences would be probably even larger. So it is questionable whether the EU should want to be dependent on a country that can impose measures like this with very, very large consequences for the EU economy and society. And secondly, these countries will also need to change to a renewable energy system themselves, and thus may need the materials themselves as well. Which may not leave enough supply for Europe anymore, possibly, especially on the short term. So clearly there is a high risk on supply constraints or disruptions for the European Union. And the EU is increasingly aware of this and also acting against it. For example, as I mentioned before, the establishment of this strategic partnership with Ukraine regarding raw materials, but also regarding other strategic products besides raw materials, such as semiconductors. I think recently the European Union installed the European Chips Act, in which they actively support European chip industries to be less dependent on other countries, for example, China. And yeah, to conclude, although renewable energy technologies increase independency for the EU on the long term, the materials these technologies contain will lead to EU dependency on other countries on the short term, and often on countries you probably do not want to be dependent on as the European Union. And countries with a central position in the mining and refining of these materials have a powerful position in the current geopolitical landscape as well. And then I'm mainly talking about China, which has a very, very powerful position in most mining and refining of these materials. Diversifying supply, for example, through mining in Europe or circular economy practices, reducing demand, for example, through different consumption patterns, and increased control over supply chains, for example, through vertical integration, can help to reduce EU dependency. And yeah, some people argue that the Russian invasion in Ukraine can be seen as the start of a new geopolitical landscape with increasing conflicts over raw materials for the energy transition. And time will tell whether this is actually the case, if we will see more conflicts over natural resources and raw materials in the future. And then I have a final message. I think most of you watching this presentation are doing research themselves. And I think it can be valuable to sometimes zoom out and consider your own research in the framework of geopolitics and see how geopolitics will affect the themes you are working on. And I think maybe it can contribute to legitimacy or momentum for your research. If you're, for example, working on circular economy practices, it can be an additional benefit that these practices reduce dependency on other countries and strengthen the European strategic position. So thank you for your attention, and if you have any questions, please feel free to ask.
Thank you, Maarten. Little hand from me and a lot of virtual hands, so that's good. Yeah, thanks for a great presentation. Any questions? Maybe I can kick it off with one question of my own. I think you gave a great overview of the materials that are needed for the energy transition, and also how the Russian invasion in Ukraine changes the geopolitical landscape in that sense. If you would combine those two and think about the resources that are produced in Ukraine and Russia and the materials that are produced there, and combine that with the knowledge that you have about how much more of these materials we will need in the future, what do you think are the crucial materials, crucial supply chains that will be influenced by this?
Yeah, so I mainly focused on the materials for electric vehicles, so I have the best overview of that. And of course, there are also a lot of other materials such as platinum and palladium that are coming from Russia for a large part. So I think for electric vehicles, it is mainly nickel, as we have seen as well, because it's such an important material in the EV batteries, and also increasingly becoming more important because because of the detrimental effects of the cobalt supply. Many battery developers are trying to move away from cobalt in the batteries, which then leads to higher nickel requirements often. So I think nickel is a crucial element and will probably be risky in the future.
And how about graphite?
Yeah, that's also, I think, an important element, and I decided not to go into it that much because of the presentation by Irina, I think last month. And the Hague Center for Strategic Studies made a very nice report on graphite. So if you want to know more about that, I would suggest you to the audience to check it out. Yeah,
I'm not sure whether she said something about because I know that for battery grade nickel, Russia is about 20%, 15-20% of the market. Do you know what it is for graphite?
Yeah, I think for graphite, Russia is not a very large supplier, but Ukraine is for graphite very important. So I think
like in 5%, 10%, 50%.
I think it's like 30% or something. So it's quite large for natural graphite. I'm not completely sure, but I think it's a large share.
Thank you. Jaco, you had a question. You're still muted.
Yeah. Yeah. Thank you for interesting presentation. Very nice to be every now and then on this series of talks to learn from this, because it's a growing topic of increasing relevance. And I wanted you to, I didn't hear you say so much about within this group of metals about this particular group that they call conflict materials. So we have the critical material, part of them are also with cobalt as the most clearest or the best known example, and I would like to ask you to elaborate on how that falls in everything you said here, because that's an extra layer of complexity or of social issues in these supply chains. And the second thing is that you probably will also know David Peck. He argues occasionally nowadays that with the the critical material requirements for the energy transition, there is a huge tension with the part of the critical material requirements for the ongoing, ICTification of society. But I don't get, and he actually argues that in order to get the energy transition done, regardless of all the political and geopolitical aspects that we focus a lot on, globally, we may have to set priority on the materials for the energy transition in order to make it happen. But that would mean that there would be less available for the ICT sector, electronics. So how does it work? Do you have any views on that? It's a bit of a broader question, and I'm looking actually for validation of this statement.
Yeah, so to address your first question regarding the conflict materials, mainly cobalt, as I also just said, yeah, cobalt is indeed, there are a lot of detrimental effects associated with the mining of cobalt, especially in Congo, child labor, corruption, armed groups, etc. And that is also a reason why also in the literature people are suggesting to remove or to try to limit the amount of cobalt more and more in batteries, for example. And I think this is increasingly being done, but still it is difficult to achieve the same efficiencies in batteries with lower cobalt contents. So this is something that is being worked on, and I think in the future cobalt will be maybe less important, but currently it's still relatively important for EV batteries mainly. So it's a valid concern, I think, regarding cobalt. And I think it is definitely very risky in that it can cause a lot of supply disruptions because the situation in Congo is so unstable, the political situation. So therefore I would also tell the EU to, well, I think they know already, to be careful with it. But it's something I think we should deal with currently. I don't know if this answers your question completely.
Well, at least for the cobalt, but of course there's quite some requirements from the electronics, and so part of the electronics too. And there are and what I understand, at least is what I read, that nickel is also considered as a conflict material. That's I'm not sure whether it's to the same level as cobalt.
Yeah, I'm not sure whether I haven't seen any sources like considering nickel a cobalt a conflict element. I mean, the definition of conflict mineral is also a bit vague, I feel. I mean, if the geopolitical situation is unstable enough, every material that is very important can be considered a conflict mineral, I would say. But yeah, I'm not sure. I think what some people believe is that we are increasingly moving towards a geopolitical landscape with more and more conflicts over minerals, whether it's nickel, cobalt, lithium. I don't think, I think they are all sensitive to be.
Maybe let me jump in for a moment. The term conflict minerals has been used in US legislation, and there it has a very specific definition, 3TG, so tin, tungsten, tantalum, and gold. Those are the 4 conflict minerals as defined in US law. Now, of course, there are many other materials which are related to conflicts here and there, but that's not the definition as it was is often used. So I think that's a nice distinction that you need to make. And if it comes to the materials, I think Dave rightfully points at the materials that we need for electronics and the communication, etc. We've done quite some project together with him, with KPN. And but what you see is first of all the mix of materials. That they're different materials often. And one other thing that you have to keep in mind is that if we're talking batteries, we're talking about hundreds of kilos of materials for billions of cars. So that's really a next level in terms of how much material do you actually need there. And often in these communication technologies, you use tiny amounts, let's say in the glass fibers and in the electronics and things like that. So in that sense, it's much less material, I would argue. But what is interesting is that it is often it's a dissipative use basically. So you use it in very small amounts, and will be very hard to recycle that stuff in the end. So you might actually lose it. While in batteries, for most of the materials, you can relatively easily recycle it.
Okay, thank you.
Arnaf.
Hi.
Hi.
Thank you for the comprehensive presentation. So you talk about the Russian invasion in Ukraine, and you talk about how it affects the nickel and cobalt supply. But how do you think it affects the neodymium, dysprosium, praseodymium that goes into the magnets of the electric vehicles? So
Yeah, I think the rare earth supply is not that much affected by this conflict because most rare earths supply is controlled by China. So over 93% is controlled by China. And also the primary production of rare earths mostly happens in China, Australia, Burma, and the US. So this is not something Russia or Ukraine are very much involved in. However, as I also said, there are rare earth reserves in Ukraine. So for the future, this could be something that is affected, that we cannot explore these reserves currently due to the war in Ukraine. But I think for now and for the short term, it's not that much affected.
Okay. And I also would like to make a comment about Jaco's statement. So you mentioned, Jaco, that we also need materials for the ICT. But we what we might look into is the secondary mine source. So we have already a lot of waste electronic equipment that's lying around, and we could use that as a potential source to that could go into the future ICT technology.
Yeah, but it's not happening very much.
No, it's not. It is not.
And the business case is great if it comes to high-end products, like where there's a lot of gold, a lot of valuable materials and silver and so on. But it's very problematic if it comes to low-end products, and then it's also problematic for again kind of materials that are used in a dissipative way. For example, tantalum, which is used in capacitors, and these capacitors are so small that they look like dust on your hand if you would have them on your hand. So that's really tiny bits, and there's tiny bits of tantalum in there. And that means that recycling of, so you can recycle some of the valuable materials relatively good. Umicore does that, but there are certain materials for which the business case is very problematic. And so either you should change that business case by subsidies or by price premiums that we are willing to pay for secondary materials, or legislation that says that, well, so much, let's say, just as a rough thing, 90% of the materials in the waste electronics should be recycled or something like that. So we should either have legislation like that or some incentive to create a business case if it's not there. Yeah.
Can you give examples for what has a good business case and what has a problematic business case?
It also depends a bit on, it's related a bit to the way in which these smelters work. For example, if you look at Umicore, there's a whole, there's a lead smelter and there's a copper and gold smelter. So copper, gold, anything connected to lead will be easily taken out. But things that end up like rare earths, they will end up in a kind of a waste flow that will not be recycled any further. They end up in flows for which there are no smelters, or it's mixed in such a way that it will be very hard to get it out. So gold, copper, tin is often taken out. Silver is taken out. Sometimes there's even things like platinum and palladium in these materials. So and the lead fraction is also used.
Okay, thank you.
And of course, the larger chunks, like aluminum, there's often large chunks of aluminum, and those are also used. But if it comes to the electronics part, yeah. Okay. Any other questions? I don't see any hands raised. Yeah, maybe Maarten, you've been looking at this broader aspect, and your advice was also to researchers to include somehow the geopolitical aspects of their research, to get some kind of broader perspective on their research, and also use that to sell their research basically. So maybe you can say something about that, because I think, yes, we are. This geopolitics is a big issue nowadays, and you can see that everybody's scrambling for resources basically. So how should you actually do that? I mean, of course, if you do something very specific, then you could say, well, this actually belongs in a broader context, so this is useful for that. Is that what you're talking about?
Yeah, I think that's what I mean. I mean, if you, for example, researching recycling of rare earth magnets, then you can. I think it's a very valuable element that it adds to EU independency to recycle these rare earth elements, because of the dependency on China, that it really helps if we have more of these supplies in Europe. So I think it's important to use that to your advantage if you're doing research, such research.
Yeah, I also think we should use our message in an even different way. I think what we should also do is to have a look at how can we influence policies, let's say, for example, design policies of products. So we're now starting to build up the infrastructure that we need for the renewable energy system, all the wind turbines, solar cells, electric vehicles, etc. Since we are now at we're gearing up, so to say, so it's going faster and faster. If we don't include circular designs, design principles in these products, it will be very problematic or more costly, both from a financial but also from an environmental point of view, to get these materials back in the end. So I think we should also use our research to show how important these materials are, and if we are not basically what I always say is we have to foster the materials that we are getting into our urban mine at this moment. So we have to foster these materials in such a way that we can get them out and reuse them at end of life. Because if we don't, we will be stuck with this mining until eternity, basically. Yeah. And then at some point, stuff will run out. Brenda.
I have a reaction to the word legitimacy on the recommendation slide, because I agree that making a case that looks into the bigger picture can help contextualize the research and also create like a storyline of how the things connect and why they make sense for a certain society or institutions or even nation. But I think that the word legitimate is quite tricky, because it really sets a stand on a desirable outcome. So I wonder, what are your views on that? And if you know about approaches to this legitimacy.
Yeah, I'm not sure if I mean it like this. I'm not proposing you to influence the outcome to increase legitimacy, but I think considering your research in light of also geopolitical aspects will broaden also the audience for your research. Because, for example, you are researching rare earth recycling, which may be very interesting for people that are developing products with rare earths, or people really involved in the rare earth business. But if you also take into account the geopolitical aspects, then you make your topic a bit bigger, and then also people dealing with strategic prospects for the EU, for example, are involved, and they can acknowledge the importance of your research. I think that is mainly what I mean with legitimacy, that a bigger group of people will acknowledge how valuable the research actually is.
Thank you. And then I think that a way to approach it from our field could be through multi-criteria analysis, because then we can connect things from different frameworks to do what you say. Oh, okay, thank you for the clarification.
Thank you, Brenda. I don't see any other hands raised, so I would like to thank you, Maarten. Great presentation, nice overview, I think, of the battery materials and the relation to the Russian invasion in Ukraine. So this will not be the last time that we talk about this topic, I'm pretty sure. So thank you all for joining again. And hope to see you all during the next meeting.
Thank you, and see you next time.
René, do you have a couple of minutes left when the others have left? Because we would meet and it doesn't come so easily.
That's good. Yeah.
Yeah.